I put out the formula sheets for you. If you need one, let me. Anybody need a formula sheet? Doesn't have one in front of them. It's on the classroom as well. But just so that you have a hard copy, don't write on the formula sheets. But that's what it's going to look like. Okay, just so you have that to use. And I'll kind of talk about that a little bit today because we're going to use some of those formulas today. And I would probably get in the habit of using that. I know like when we did chapter 10, we had our own formula sheet, but you want to get used to using this because that's the formula sheet you're going to have for the final. We just tried to put everything in one formula sheet rather than you trying to use 2 or 3 different formula sheets from all the chapters that we've done. Okay. When we do this first one here, I'm not going to put a right angle in here because we don't know if it's a right triangle yet. We're trying to decide, is it a right triangle? If not, is it acute or obtuse? Okay, so we have to decide between those 3. We still do the A, B, and C. But what we do a little bit differently here is we always put C squared on the left and A squared plus B squared on the right. What that, and I'll show you why and kind of get you to remember why we do it that way. C is still the biggest. The A and B are interchangeable. It really doesn't matter which one's which. Okay, and then we're going to figure this out. So 14 squared is 196. 10 squared plus 11 squared would be 221. Okay? If these two were equal, we would say it's a right triangle, but they're obviously not equal. Okay, so it's not a right triangle. So now we have to decide, is it acute or obtuse? And that's why we always put C squared on the left, because we're going to say that 196 is less than 121. And when we think less than, when we think of an acute triangle, we think of small angles, right? And so less than means smaller. And so here, because 196 is less than 221, we would say this is an acute triangle. If it was greater than, it would be obtuse. And if it's equal, it's right. Okay? So that's how we decide for those. Number 2 would be the exact same thing, just different numbers. Okay. Hey. Okay, so I will let you use the special triangles if you still have them, okay? If not, they're going to be on the formula sheet, okay? The only bad thing is you really can't like flip them and move them around like you can with the other ones that we made. So if you have them, you can use them. If not, it's on the formula sheet. You just have to remember the relationships more than anything else. The 2 legs on a 45, 45, 90 are A, and then the hypotenuse is A radical 2. And then same thing would be here. And then on 5 and 6, these are 30, 60, 90 triangles. Opposite the 30 is always K. Opposite the 60 is K radical 3. And the hypotenuse is always 2K. Okay, those are your relationships. And you don't necessarily have to memorize them. They'll be on the formula sheet, but you just have to kind of know how to use them. more than anything. Okay, so for instance, like, let's do number 5. The side that we know is opposite to 30, so that is my k value. So what we're going to say is that k is really 9. So because k is 9, then x would be 9 radical 3. And then y would be 2 times 9, which is 18. So the math on most of these is not overly difficult. The hardest ones are when I give you like this side here. If I told you this side here was like 12, then I would have to set 12 equal to k radical 3, and then I'd have to divide by radical 3. Those are the ones that are a little bit harder. But most of the time, if you know the relationships, the math's not too bad. Okay, I think this is probably the one that gets people the most. This is probably the most confusing one for some people because we're not solving for a side or an angle. We're just writing the relationship. Remember, sine, cosine, and tangent are ratios. So that's what this is asking us to do, is just write the ratio, change the ratio to a decimal. Okay? So they say tangent of r to start with. From angle r, we're doing tangent on this one. So tangent is opposite and adjacent. Opposite is across from the angle. Adjacent is next to. This would be my hypotenuse, which we're not using here. Okay. When I write the ratio, the tangent of r is opposite over adjacent. So I put opposite on top. I put adjacent on bottom. So I have 45 over 28. That's my ratio. That's all you got to do. We're not finding the length of a side. We already know the side lengths, okay? We're writing the ratio. The second part, it asks us to do, write each one as a fraction, which we already did. If you can reduce it, we would reduce it. It doesn't reduce. And then put it in the decimal to 4 decimal places. So if I do that, this would become 1.6071. And that would be our 2 answers. One's as a fraction, one's as a decimal. So those are not solving questions, those are just writing the ratio questions. Okay, same thing on this page. Then we get into like some of the sine and cosine. Just remember, like when you do problem like number 10, I'm going to use the angle that we know, 32 degrees, and you have to set up 2 different problems. One is for x, one is for y. So if I wanted to solve x first, from 32 degrees, this would be opposite, this would be my hypotenuse. Okay, so we have O and we have H. So O and H is the sine. So the sine of 32 degrees equals opposite over hypotenuse. Write the equation out, okay? Once I have the equation, basically x can be in 3 spots. X could be on top, x could be on bottom, or x could be the angle. If x is on top like this one here, I'm just going to multiply by 18. If x is on bottom, we're going to do the flip-flop, where we trade places there. If x is the angle, that's when we use the -1 button, okay? -1 buttons, anytime you're looking to find an angle. So on this one, we just multiply by 18 and take 18 times the sine of 32. Make sure you remember how to do all that in your calculator and everything. Find the side. And then I'm going to do a second one for the y, to find y. Okay, then you got a couple of kind of story type problems where you're trying to find, I will tell you, number 12, you can either do trig or you can even do a 45, 45, 90 triangle, okay? Either way would get you the same answer. Number 14, whenever it says to solve, you're going to find all missing pieces. So we're looking for AC, we're looking for angle A, and we're looking for angle C. Okay, AC is the hypotenuse here. We know 2 out of the 3 sides. So when I know 2 out of the 3 sides, then what would I do? What would be the best way to solve for AC here? Yep. If I know 2 out of the 3 sides and I have a right triangle, it's just a squared plus b squared equals c squared. Okay, these are my 2 legs, and we're trying to find the hypotenuse. Okay, to find the angles, let's say I wanted to find like angle A first. Really doesn't matter which one you find first. I'm going to use the 2 sides that we know, which are opposite and adjacent from angle A. So we're going to write tangent of angle A equals opposite over adjacent. Okay, first step is to always write the equation out. If you don't write the equation out, then it's going to be harder to figure out what you have to do. Take the time to write it out. We're going to solve for A, angle A, but because we're looking for an angle, this is the one where we have to do the tan negative 1. So we're going to do tan negative 1 of 24. Once again, make sure you remember how to do that in your calculator. Then we can do the same thing for C. Always remember that A and C are going to add up to be 90 degrees. So that's kind of a way you can check yourself, is do they add up to be 90? Okay, starting with number 16, we're into chapter 10. Okay, chapter 10, there's a lot of formulas on the formula sheet that are chapter 10 formulas. Most of the formulas right there in the middle of the page are your chapter 10 formulas, okay? And it says angles and it says segments. And so that's why I really encourage you to use that formula sheet as you're doing your review, okay? If you do the one that we had way back when, it's the same formulas, but I just want you to get in the habit of looking at this formula sheet, knowing what problems it goes with, okay? And so for instance, if I look at number 19, it's asking us to find angle A. So it's an angle, right? Hey. Do you want to try to do the whole thing? You think so? Okay. Which one do you do that? Yeah, I'll take it over this one. I'll be right back, guys. So the formulas aren't really that hard, right? All we got to do is look at it and say, what do we got to do? So where is angle A at? Inside, outside, or on? are the three answers we could come up with. It's on, right? Angle A is on the circle because that's where the two segments meet. So if it's on the circle, we're going to find the arc that it opens up to, which is 84 degrees. And we're going to take 84 divided by 2. Okay? Not a hard math problem, but just we got to figure out which formula are we using. That's the hardest part. Sometimes I know the angle, and I got to double it to get to the arc. So just which direction we going, how we're going to get there. Okay, last page, using those same formulas right there in the middle of the page. First thing, are we looking at angles? Are we looking at segments? So if I jump down to like number 24, for instance, we label this A, B, C, and D. And this is the one where we do A times B equals C times D. The one thing you got to be careful of is when I do this, I want to put the x minus 3 in parentheses. If I don't put x minus 3 in parentheses, I'm going to forget to distribute. And now we just solve for x. I'm going to take 9, I'm going to distribute it, solve for x. Just a pretty basic equation to solve from there. 25 is one where you are still finding a segment, but you have an inside and an outside. We did some of those. And then this one here, this formula is also on your formula sheet, and it's right there in the middle of your page also with the rest of those chapter 10 formulas, and that's the equation of a circle. X minus h squared plus y minus k squared equals r squared, okay? So not all of the formulas tell you what they are, you just have to know which one goes with which, okay? So that's, once again, why I encourage you to look at the formula sheet that I'm going to be giving you for the test, so you know kind of how to use it and what goes with what. Okay. All right. I'm going to let you guys work. I posted answers